Hello everyone. Today we're going to be going through an MCQ, no calculator practice test from the Princeton Review. With the BC exam coming up in a couple of days, I thought it'd be good for people that are watching this video who are taking the BC exam next week to practice and prepare their general MCQ strategy and work on what they need to work on for calculus. So with that in mind, I'd encourage you guys to pause the video and try some of these problems yourself before looking at my solution. And without further ado, let's get started with number 1. If 7 equals xy minus e to the xy, then dy dx equals, so we're going to differentiate with respect to x, right? So we're going to get 0 equals, if we apply the product rule, we get y plus x dy over dx as the derivative for xy, and minus e to the xy, chain rule, you have to differentiate the exponent, which is x divided by dx plus y. Right, equals, this equals 0. We're also going to isolate the non-dy dx terms from the dy dx terms. So we get 0 equals y minus e to the xy times y, right, plus x dy dx minus e to the xy times x times dy dx. So we're going to subtract off the non-dy dx terms, and then we get y e to the xy minus y equals x dy dx minus x dy dx e to the xy. Right, and I'm factoring in e to the xy minus 1 from both sides. We get this, y times e to the xy minus 1 equals x dy dx 1 minus e to the xy. Then we can divide these off and put a negative sign right here. So it turns out that dy over dx is just negative y over x. And that's choice D. Okay, moving on to question 2. The volume of the solid that results when the area between the curve y equals e to the x and the line y equals 0 from x equals 1 to x equals 2 is revolved around the x-axis is. Okay, so let me get a general idea for what we're trying to find the volume of. So they said from x equals 1 to x equals 2 around y equals 0, which is the x-axis, and they said our function is e to the x. So our area will look something like this, and we want to revolve around the x-axis. So I'm just going to use the disk method, so that'll be pi 1 to 2 e to the x squared dx. Now the antiderivative for this is just pi over 2 e to the 2x, and we're going to evaluate between 1 and 2. And this will give us pi over 2 e to the 4th minus e squared. And that's b. Okay, let's move on really quick. We have partial differentiation. So we're going to represent this big fraction right here as the sum of two smaller fractions with only one of the factors of the common denominator present in each fraction. So it will be a over x plus 3 plus b over x minus 4 equals x minus 18 over x plus 3 x minus 4. Right. So now what we're going to do is we're going to multiply both sides by the extended common denominator. I'm going to get a times x minus 4 plus b times x plus 3 is equal to x minus 18. Right? And now we're going to do something here. I'm going to draw up a systems of equations. We're going to get a plus b is equal to 1 based on the coefficient, right? And we're going to get negative 4a plus 3b is equal to negative 18. Right? So I'm going to multiply this equation by 4, which gives 4a plus 4b equals 4, and negative 4a plus 3b is equal to negative 18. That'll give us, when we add it up, we get 7b, right, if I'm not mistaken, it's negative 14. That means b is negative 2. And then when we look up, we see that a plus b has to equal 1, so a has to equal 3. Right, so our function will look like this. It'll look like 3 over x plus 3 minus 2 over x minus 4. That dx right, and which option does that match? That matches option E. And we're done with that question, so let's move on. Okay, if y equals 5x squared plus 4x and x equals ln t, then dy over dt equals, okay, so from the parametrics unit, we know dy over dt over dx over dt is dy over dx. Now this means that dy over dt over dx over dt, which is 1 over t, is equal to 10x plus 4. So dy over dt is equal to 10x plus 4 times t, but we know what x is. We know x is ln t, so that's just equal to 10 ln t plus 4 times t, which is 10 t ln t plus 4t. That's b. Okay, and we move on. We got an integration question. The integral from 0 to pi over 2 of sine fifth to the x cosine x dx equals. Now, given that we have sine and cosine in the same integral, this screams u substitution. So what I'm going to do is I'm going to say u equals sine x. And that way du equals cosine x dx. Right? I'm going to change my bounds. I also have to change my bounds. Sine of 0 is 0. Sine of pi over 2 is 1. So it'll be the integral from 0 to 1 of u to the 5th du. And that's just u to the 6 over 6 from 0 to 1. And that's just 1 over 6. Alright, that's A. Let's move on. The tangent line to the curve y equals x cubed minus 4x plus 8 has, at the point 2, 8 as an x-intercept of. Okay, so first, in order to find the tangent line, we need to find the slope. And for that, we need to find the derivative. So dy over dx is 3x squared minus 4. And we need to evaluate this at a point with x coordinate 2. So we're going to do that. We're going to plug it in. We're going to get 3 times 2 squared minus 4, which is 12 minus 4, which is 8. Right? So our tangent line is y minus 8 is equal to 2 times x minus 2. Or not 2, 8. 8 times, because that's our slope. And we need to find the x-intercept. So we're going to set y equal to 0. So we're going to say negative 8 equals 8 times x minus 2. This means x minus 2 equals negative 1. That means x equals 1. So our x-intercept is at 1, 0. That's perfect. And we move on. The graph in the xy plane represented by x equals sine 3t and y equals 2 cosine 2t is blank. Okay. So we have the equations x equals 3 sine t and y equals 2 cosine t, right? Now let's square these. Get x squared plus y squared. Sorry. Let's deal with them separately for now. We'll get x squared equals 9 sine t squared, and y squared equals 4 cosine t squared. Right? And if I do x squared divided by 9 equals sine squared t, and then y squared divided by 4 is cosine squared t, then I get x squared plus 9 plus y squared divided by 4 is 1 by the Pythagorean identity, and that'll just look like an ellipse. That'll be this ellipse. It'll be an ellipse. That's the equation of an ellipse. So our answer choice is B. Okay, and now we have a question here. Alright, we need to find the indefinite integral of dx over the square root of 4 minus 9x squared. Okay. So it looks like if you know the formula for the antiderivatives of these types of expressions, you can just use that and plug it in. Otherwise, well, you're going to have to follow along and watch as I do a u sub. Okay, so let's start with u sub. What should we u sub? We can do sine, cosine. Since all of our options are in inverse sine, I'd rather substitute sine expression. So we're going to substitute x equals 2 over 3 sine theta, for example. What that will give us is x squared is equal to 4 over 9 sine squared theta. 9x squared equals 4 sine squared theta. And then you get the point, right? So, and then we'll find what dx is. So dx is 2/3 cosine theta. And now that's all left to do is plug it in. Right? So dx is 2/3 cosine theta, d theta. And on the bottom we'll have 4 minus what we calculated here, 9x squared is 4 sine squared theta. Right? And this is equal to 2/3 cosine theta, d theta, over 2 cosine theta, because that's what it is. 4 minus 4 sine squared theta is 4 cosine squared theta, and the square root of 4 cosine squared theta is cosine theta. Right? And so we get the integral of 1/3 d theta. Right? And this is just 1/3 theta plus c, but remember, we want our our answer in terms of x. Right? So we're going to solve for theta in terms of x. We know x is 2/3 sine theta. Right? And then we know 3/2 x is equal to sine theta. And we know theta is equal to the inverse sine of 3 over 2x. So that means our answer in terms of x is 1/3 inverse sine 3 over 2x plus c. And that's option E. And we're done with that question. Number 9, limit as x approaches infinity of 4x times sine of 1 over x is. Okay, so since 4 is a constant, I can factor it out of limit. So we get 4 limit x approaches infinity of sine of 1 over x times x. I'm going to write this limit in a more enlightening way. So I'm going to write it as limit sine 1 over x over 1 over x. This is the same thing. And if you notice, the argument of the sine expression matches the denominator. And this rings a bell about the special limit as sine x over x as x approaches 0. Right, so I'm going to introduce a new variable y. I'm going to say it's 1 over x. Right, so this will be a new limit as y approaches 0. Since as x approaches infinity, y approaches 0, of sine y over y. And this is just equal to 4, right? Because our special limit x approaches 0 of sine x over x is 1. That's what we used here to solve that problem. Okay, number 10. The position of a particle moving along the x-axis at time t is given by x of t equals e to the cosine 2t for t between 0 and pi inclusive. For which of the following values of t will x prime of t equal 0? Okay, so we got to do some differentiation here. So we're going to get x prime of t is equal to e cosine 2t, and then we have to differentiate cosine 2t, which will be negative 2 sine 2t, right? So which values of t that are listed here will make this expression equal 0? So what happens if we plug in t equals 0? Well, we get e to the cosine 0 times negative 2 sine of 0, right? So that works. Same thing if we plug in pi over 2. Plug in pi over 2, we get negative 2 sine pi, which is also 0. Plug in t equals pi, we get negative 2 sine 2 pi, which is also 0. So the answer is all of them, 1, 2, and 3. Okay, number 11. Limit as h approaches 0 of secant pi plus h minus secant pi divided by h. Now, this is the limit definition of a derivative if you don't recognize it. And this is just equal to f prime of pi, where f of x equals secant x. So f prime of x equals secant x tangent x, right? So f prime of pi equals secant pi times tangent pi, which is equal to, I'm pretty sure, negative 1 times the tangent of pi is sine of pi over cosine of pi, that's 0. So the limit is equal to 0. Use differentials to approximate the change in volume of a cube when the side is decreased from 8 to 7.99 centimeters. So our volume in terms of its side length is x cubed, right? And we're trying to find the change in volume when the side is decreased. So the change in volume, dV, will be equal to 3x squared times the change in x, right? And we're going to approximate it at 8, since we go from 8 downwards. Right, so that'll be equal to 3 times 8 squared times negative 0.01, which will be 192 times 0.01 times negative 1, which will be negative 1.92. And that's the answer to that question. Okay, let's move on. Alright, the radius of convergence of the series is, okay, so we'll perform the ratio test on this. So a to the n plus 1 over x plus 2 to the n plus 1 times x plus 2 to the n over 8 to the n, right? This will be equal to the limit as n approaches infinity of 8 over x plus 2, right? This has to be less than or equal to 1. So a divided by x plus 2 has to be less than or equal to 1. Okay. So how would we approach this problem from here? Right? So we know that the absolute value of a cannot exceed the absolute value of x plus 2 under any circumstance, right? So where can x lie, right? A is a constant, a is positive. So let's take two cases. Let's say x is greater than negative 2. In that case, we have a is less than x plus 2, right? And that's what it means. And then in case x is greater than, x is less than negative 2, then we have a is less than 2 minus x, which means a is greater than x minus 2, right? And since all of these inequalities have x in the middle, let's try and isolate x in both of these inequalities. Sorry, this should be negative 2 minus x plus, right? So we have a minus 2 should be less than or equal to x. Hold up. A minus 2 should be less than x. Right? Or when x is less than equal to 2, let me solve this equation really quick. So a plus 2 x right, and then we get negative a minus 2 bigger than x, right? So that's your bounds right there. Those are your bounds. And what it looks like is this compound inequality corresponds to option D. And we're done with that problem. So number 14. We have to integrate from 0 to 1 of inverse sine x dx. Okay. So we're going to integrate by parts. We have u dv. Obviously, it's much easier to derivate inverse sine than integrate it, right? So we're going to have dv as x, 1. We're going to have dv as 1. So then that'll be x, and it'll be 1 over square root 1 minus x squared. And then we can stop. Plus minus, so we'll have x sine inverse x minus the integral of x over square root 1 minus x squared dx. And then if we do a quick u substitution, right, we say u equals negative 1 minus x squared du equals negative 2x dx. 1 half to the negative 1 half du, right? Again, this will equal x sine inverse x plus 1 half times u, which is 1 minus x squared, to the, what is it? To the 1 half power right? Times 2, right? So cancel this will cancel. So in reality, we're differentiating. Our antiderivative is this. This is our antiderivative, and we're going to go between 0 and 1. So let's plug this in really quickly. Okay? So when we get 1, what do we get? We get 1 times inverse sine of 1, which is pi over 2, plus 1 minus 1 squared to the 1/2, that's 0. Okay, that's minus. And then we get 0 times sine inverse of 0, that's 0, and then plus 1 minus 0 squared to the 1/2, that's 1. So we get pi over 2 minus 1, that's option C. Okay. Number 15. The equation of the line normal to y equals that expression had x equals 2